term is negative 50. All right, so there is information that U1 is negative 50. We also know that the last term, and there's 20 terms, so U20 must be 83. What I don't have is the common difference. But I actually don't need to find the common difference in this question, because one of my arithmetic series formulas says that I can just take the number of terms in the series divided by 2 and multiply it by the first term plus the last term. Now, I am going to do a little bit more work on this question after I solve it, because I just want you to see how we could find the common difference if you needed it. But if we're going to do this the quick and simple way, we've got 20 over 2, which is multiplying the sum of the first term and the last term, giving you an answer of 330. But I did want to show you, just remind you that if you know what a particular term is, you could also use this formula to help you learn missing pieces of information. Right? This is your general term of an arithmetic sequence formula. And if you know that your 20th term is 83, that is to say, the value of the term is 83 when n is 20, and you know that your first term is negative 50, see, and now you could solve for your common difference if you were sufficiently interested. That's what the question was asking. I bring the negative 50 over, and then I can divide everything through by 19, and I'll find that D is 7. It's not relevant if I had used this method, but if you had been insistent upon using the other arithmetic sum formula, that starts the same with an n over 2, but instead of describing this part as u1 plus un, we describe it as 2u1 plus n minus 1d. So this version of the arithmetic sum formula is useful when you don't know the last term, but you do know the value of d. And so now we know the value of d. You could also use this formula, and you'll still get 330 as your arithmetic sum. How about a geometric sequence problem? Okay, so if these are in geometric sequence, remember the definition of arithmetic is that we have a common difference, meaning that the difference between each pair of consecutive terms must be the same. Well, in a geometric sequence, they all have a common ratio. So the second term divided by the first term will be in the same ratio as the ratio between the third and second terms. Don't forget that you need to change the order of the terms when you're either subtracting or dividing them. We're doing the third divided by the second in order to find out what that common ratio is. Okay, so this thing is the common ratio, this thing is the common ratio, and because the ratio is common, these things must be equal to one another. Now we can cross multiply, right? Anytime you got a fraction equals a fraction, you can cross multiply 5x plus 4 multiplied by itself. Sorry, 5x plus 4 multiplied by itself must be equal to, and then we've got this cross as well, k plus 4 times k plus 20. Sorry, these should have been k's, shouldn't they, not x's. Oops. All right, let's expand. 25k squared. Middle term is 40k. 4 times 4, 16. And now I can bring everything to the same side of the equation to get a 0 on one side, because anytime I'm solving a quadratic, of course you want a 0. And before we start messing around with these big numbers, look to see if there's a common factor through which you could divide by. And there is. We can divide everything through by 8. So 3k squared plus 2k minus 8 equals 0. This does factor, as most quadratics will in this course, right? And you'll discover then that there's actually two different possible values of k that will form three terms in a geometric sequence. K could be equal to 4/3, or k could be equal to -2. And we can demonstrate this by actually making the substitution. If k were equal to 4/3, or 1 1/3, k plus 4 would equal 5 1/3, or if you prefer, 16/3. 5k plus 4 is going to be 20/3 plus 12/3. That's 32/3. And k plus 20, that's going to be 4/3 plus 60/3 gives you 64/3. And we see that what's happening each time, yes, look, it is geometric. We're always multiplying by 2. Right? Each fraction is 2 times the previous one. Wow, got 2 Google Meets open and a million other apps. My computer is about to burn up. Boy, it's too hot to touch. Probably gonna turn off in a minute. You could also substitute in -2, and you'll discover then that you get 2, -6, and +18. And those do form a geometric sequence with a common ratio of -3. Okay. Last couple of problems are here. And while these could be done algebraically, they do lend themselves extremely well to the finance app on your calculator. So I'll show you how to do the first one in a formulaic way, but then we'll talk about calculator methods for both of these problems, and then we'll finish. So your future value in a compound interest situation, or in a depreciation situation, whether the value is increasing or decreasing by a certain percentage every time period, we take our present value, and if it was depreciation, we would be subtracting the interest rate or the depreciation rate. Because this one is interest and the value is actually increasing, the value of the loan is getting bigger, I'm going to add. So 1 plus the interest rate. Now look, the interest is compounded half yearly. That's twice a year. So our 12% per year needs to be divided by 2 in order to find out what the half yearly amount is. And at the end of 5 years, now how many compounding periods is this? Well, if you have a half year, each time that we're compounding, half year, how many half years are there in 5 years? Well, there's 2 half years per year, and we're looking at 5 years. Okay, so there's going to be 10 compounding periods. Sorry, my present value, of course, I could have substituted to be 20,000, couldn't I? All right, so 20,000 multiplied by all of this would be one way that you could get a future value. The other way would be by grabbing your calculator, and again, I'm going to have to dictate. I'm sorry for that. I'll have to dictate what you would do. If you need a reminder, press menu in the Scratchpad. Menu. Go down to option 8, finance. Go to finance solver. Now, capital N represents the number of compounding periods. If we're compounding every half year, so twice a year, for 5 years, that is 10 compounding periods. So capital N should be 10. Your interest rate is 12 because it's expressed as a percentage, not as a decimal. So 12 we put in. Your present value We always like to put in as a negative value. Currently, I am loaning 20,000. So I'll put negative 20,000. I'm going to pay it all off at the end of 5 years. I'm not making regular payments, so my payments are 0. And my before I go to future value, because that's what I'm about to solve for, I need to go down to PPY. That's payments per year. I'm actually not making any payments per year. What I care more about is that my compounding periods per year would be 2. And if the payments per year isn't going to matter because I'm not making any payments, my payments are 0. So I don't actually think they'll affect anything. Most people just tend to put their payments at the same rate or same value as their compounding rate, because if you were doing two payments per year, chances are it's compounding twice a year as well. All right, and once you've got 2 as your PPY and your CPY, because we're compounding half yearly, you can go to future value, hit enter, and you'll find that the amount of the loan is 35,816. Boy, really? That's pretty crappy. I mean, you have to pay back almost double the amount. Tough. Wow. Well, I guess if it's 12% a year for 5 years, you might expect that to be at least a 60% of your original amount, right? Okay, so your total amount, dollars, we should round to 2 decimal places. So 35,816.95, 95 cents. If you wanted to round to the nearest dollar, then you could also write down 35,817. And if you wanted to round to 3 significant figures, you could round it to 35,800. All of these answers are correct because you were not given a level of precision to round to, so you can choose between any of these 3. And the last problem is very, very difficult to do by hand. It can be done, as you may remember from the formative task. There is an amortization formula out there, and we can find the amount of the monthly payment or the periodic payment. In this case, it's every month. But I reckon we may as well just do this with the calculator again. So again, we're going to go to the same thing. Go to the Finance Solver. So Scratchpad, Finance Solver. And let's put in the information. Your capital N. If you're paying off this loan every month over a period of 7 years, 7 times 12 will be the number of payment periods. That's 84. So your capital N is 84. 84 total payments over the 7 years. Your interest rate has been given as 12.5. He's borrowed 7,500, so let's choose negative 7,500 as the present value. I'm going to skip payment because that's what I'm going to come back to. It says, what is the amount of each monthly installment? It's asking me for the monthly payments. Let me skip it. The future value of the loan is 0 because you've paid it off completely. There is nothing left owing. Payments per year, it's monthly, so it's going to be 12. And that should, I think, oh, dang it. Let me just scroll down. Yeah, that looks good. And then I can go to my payment, which is what I'm trying to solve for, and hit enter. And it will tell you that your monthly payment that you'll need to make each month for 7 years is $134.41. $134.41 when you round to the nearest decimal place. And lastly, it says, oh, whoops, not quite lastly, what is the total interest charged on the loan? So if we're making 84 payments of 134.41, so let me multiply these amounts. $134.41 multiplied by 84 gives me 11,290. .4. And of course, we had originally borrowed 7,500. So how much is Kevin paying in interest? When we do the subtraction, Kevin not only owes the $7,500, he also has to pay like more than half of that amount in interest. You see why getting into debt is such a bad thing? Oops, I missed a decimal place on the previous. There we go. Okay. All right, so there's the amount that he pays off in interest. Okay, that's the total amount that he paid, and then of course minus the original amount. The difference will be the interest. Find the equivalent flat rate of interest. Actually, we didn't do this. No, we didn't do this in our course, so don't worry about that part of the question. I'll put these questions together into a PDF. I know there's a couple of people who missed class and will want to see the problems that we worked on. Feel free to share with them some answers that we've worked on together in case I am unable to include those. And of course, in MYP, grade 10, there is no homework being assigned, but feel free to do any additional study that you wish on sequences and series and on differential calculus and optimization and all of that material that we've covered in Unit 4 so that you're prepared for the quiz this Wednesday. I'll stop sharing my screen and just come back to the call and see if there's any final questions. Anyone want to ask anything before we say goodbye? Okay. It looks that way, Ravi, yeah. I mean, final test is scheduled for, I think, like Wednesday, what do we say, Wednesday the 27th? Thursday, May 28th would be your final exam. So yeah, in the absence of any options, yes, we'd have to do it online. I'd have to have your cameras on and be supervising you as you write it. Maybe we can even make tomorrow's quiz like a practice for that. Perhaps I'll make you turn on your cameras and I'll watch you as you write your quizzes so you can get a sense of what it would be like. Last year we covered all topics from the year in the actually, no, this is a cumulative test. This is going to be for everything. So tomorrow, the formative quiz that you write is only on Unit 4, only on sequences, series, and differential calculus, because we haven't given you any kinds of evaluation whatsoever, any kind of practice criteria A assessment on that material. But your Unit 4 test is actually not Unit 4 only. It's cumulative end of year on the entire year's material. Yeah. Okay. Any other questions? No problem. Thanks, guys. Thanks for joining us. We will see you next on Wednesday for your formative Unit 4 quiz on sequences, arithmetic and geometric and series, financial applications, derivatives, optimization, tangents, normals, differential calculus. You get it. Have yourselves a good day. Thanks, guys. We will see you on Wednesday. Bye.
Thank you. Bye.
See ya.
Thank you.
Guys, bye-bye.